everybody, ready to do it again?
Good morning, everybody.
You're fine. No, Levi, ready? No, do it like standing up. Yeah. No, no, you did. Yes, I did, ready? I got you. You're so weak, you know, like. You don't.
They don't understand you guys.
Because it hurt. What about the edge?
I did that. Wait a minute, whatever else has that will join in. We are gonna, we're starting the first actual lesson on circles. So if you go in, I actually wanna turn this on. Go ahead and log in and click on your live lesson. Make sure you stay on slide 1. Give it a minute till everyone logs in.
At least it's hiding on zero time. I am though. You know what's makes the most weirdest noises?
The most weirdest noises.
Weird.
Ah, so sorry, I'm restricting you to screen 1. I can see that you're all the way done, but there's no way. We're all there. Okay. So we're gonna talk about circles, talk about parts of circles, measure some circles, find the special number that makes a circle and its measurements proportional. It's gonna be so fun. Are you excited?
No. It's supposed to be Friday. Say it's Friday. Well, how you're making us do this is makes it feel like Monday.
All we ever have is Fridays and Mondays. Right? And then when we come back next period, there's a set of practice problems. You guys are gonna work on the project. You guys at home didn't get the project yet. I'm waiting until you come in person. It's like just a strictly working class type thing. That way you don't have to do it. But I'll explain more of that. Second period or 9th period, but you guys at home don't have to worry about that. We're gonna go through this lesson and then there's just a set of practice problems that you at home are gonna do. And that's it. That's our Easy Friday. So does anybody know what any part of a circle is called? Any part of a circle.
Line.
Chris?
Curvy line.
It's a curvy line, yes.
How?
It's a part of a circle. Has anybody heard the word radius before?
Yes.
What's the radius?
I don't know. From you, we've heard it from you.
Anybody know what it is?
It's a line. Let's go into the square. Let's go into the line. Let's go into the circle.
The radius of a circle is the segment from the center to an edge. So not the full distance, just from the center to the edge. So you can see point P in circle 1 is the center. So down here in question 1, or I'm sorry, let's come over here to circle 2. I started talking about radius first. The radius of a circle is the length from the center to the edge. Name a radius that's in circle 2. So type 1 in. It's the length from the middle to the edge. So there's a couple different options. Just familiarizing ourselves with the vocab and the words. Radius is from the center to the edge. So you're naming the sign, the length. So when you name a length or a segment, it's the 2 points that make it up. So if my center point is Q, what's another point that makes a radius? J. So if I want to name the radius, I can name segment QJ. What's another one? Alina? QH. First? QI. And then my last one would be QG. Okay? Your radius is just that halfway point in your circle. Have you heard the word diameter before?
Yeah.
What's a diameter?
Don't know.
But you've heard it.
I've heard it. I've heard it from you.
Your diameter is the entire length through a circle. So I have 2 radiuses that make up a diameter. Okay, so if I look at circle 1, What's one segment that's a diameter? Edge point to edge point.
So do we have to like multiply or something?
Nope, we're just looking at that circle, looking at the letters. Name one segment that goes all the way through the whole circle. Chris.
EF.
EF, I go from point to point, straight through the center. What's another diameter? Rich?
AB.
AB, Sydney, what's the last one?
CD.
Right. So your diameter is that whole length across, your radius is the half length.
EC.
Well, AC doesn't go through the middle. You always wanna make sure you're going right through that center point. DC, yeah, that's right. Okay, diameter goes through the whole thing, radius is half of that. Have you heard the word circumference before I've said it? Circumference is the length all the way around your circle. So you've heard, when you were doing some geometry stuff, you've done perimeter and areas. What's a perimeter? Sydney?
All the sides.
Right, so if you have like a geometric square or triangle, your perimeter is the length outside. In a circle, we just call that the circumference. So it's the entire length of your outside portion. Okay, so that's the three parts you want to be familiar with. Circumference is the length on the outside, diameter is the full length across, and your radius is your halfway midpoint. So now we can see two circles, and we can just talk about the questions. Question number 1 says, what is the same about the two circles?
The lines,
They're both round. What'd you say, Parker?
they're both round.
Did you see something else?
They both have lines.
They both have lines in them. Anything else that's similar about the two circles?
There's dots.
Okay, so I see some points inside of them. I see some radius, some diameter.
They're like, they're like and H and G, like they're connecting like that, but A to A and C is like getting interfered with E and B and D.
So RJ's noticing that in I think he's trying to say that in the second circle, you can see the diameter HG as 8 centimeters. And then in the first circle, the radius CA is kind of like coming in and cutting that same diameter EB. What is the length of AD? So if I look at the first circle, I see from C to A is 4. What's my length of D to A gonna be? 4. In a circle, no matter where you draw the radius, it is always the same length. DA is 4, AE is 4, AB is 4. The radius is the same throughout the whole circle.
So for the second one, it's the same.
It's 4. On the first circle, so here, what's the diameter in circle 1?
8 centimeters.
That's my second question I'm gonna ask, so I'm gonna come back to you, Parker. What is like the name of the segment that's the diameter? What 2 points make up the diameter? Sydney? EB. So then Parker, what did you say the length was?
Just like never recorded.
Centimeters.
How did you know it was 8 centimeters?
Because it's right there.
Because it's right there. I can see that they're the same. My diameter here is 8. How else can I look at this circle and know that it's 8 centimeters? Sydney?
The small lines are 4 and the small lines are half.
Right. So my radius is 4. 2 radiuses make up 1 diameter. So if I have 4 and 4, all together they make up the diameter of 8. Then just getting used to the parts and pieces of a circle. Your radius is your halfway point, your diameter is your full segment. So if your radius is 3, what's the length of your diameter? 6. If your radius is 10, your diameter is 20. It's just multiplying it by 2. So now we're gonna get into measuring some circle pieces. So first we have that Claire wonders if the height of a toilet paper roll is the same or greater than the distance around. So she's looking at this and she's trying to figure out, what do we think? Is this height piece greater than or the same as the distance around? What do you think? So we think the height's greater. What else? Any other ideas? Do we agree? Do we disagree? Huh? It's cylinder, but which segment do you think is bigger? The height or the circumference or the distance around?
The height.
The height. How can we be sure, or what can we do to figure out which one's bigger? We can measure it, right? So that's kind of what we're gonna go through today, is look at a couple of these different shapes, measure the height, measure diameters, measure circumferences, and figure out a relationship between the two of them. I'm gonna switch the slide. Those of you at home are just gonna have to listen and wait for us to type in the objects. We have 4 objects that we're gonna measure during class. And I'm gonna pick somebody to measure one of each. First object is a Pringles can, okay? So in your table, for object number 1, type in Pringles. We need to measure the diameter. Who wants to measure it? Okay, so I'm gonna take Chris over a measuring tape. And he's gonna measure the diameter. When we looked yesterday about how measuring can kind of be a little tricky, you're trying to be as precise as possible. So he's measuring straight across the top, because that's our diameter.
7.5 inches.
It's about 7.5 centimeters. Okay, so for your diameter, for your Pringles can, type in 7.5. The next thing we're gonna measure is the circumference. So I'm gonna do this one, so that for the next one, you guys are gonna know how to do. Where's the circumference on this can? RJ?
Is it the lid?
What about the lid?
Is it, the circumference is like the top of it?
It's the top of it, it's your distance around. So there's 3 other objects I'm gonna have somebody measure. When you go to measure your circumference, you're wrapping it around to figure out what that length is. And you're estimating it. I got my circumference for the Pringles can to be about 24.2. Okay, so make sure you type that in. Our next object is a roll of tape. 24.2. So for your next object, tab over, say tape. Who wants to measure the diameter of the tape? Try to be as accurate as possible.
Circum?
Diameter. It's on the circle part. Hold on. There it goes that way.
11.
It's about 11. Might be a little bit past 11. I might say 11.2.
Oh, it is 11.
It is? Okay, so we can go with 11. So the diameter of your tape is 11. You want to measure their circumference? Go ahead. So now we're measuring the circumference, which is your distance around the whole piece. What'd you get?
Okay. I got 35 and a half
35 and a half.
because I measured where that line is, that. Right there.
Yep.
That line.
So about 35.5 for your circumference. Our next object is a mint can jar. Who wants to measure mints? As accurately as possible, Elena is measuring the mint straight across the top. Tell us what our diameter is. 8.5. Got a little bit smaller.
What?
8.5. It's about 7.5. 7.5. So then our circumference is that whole distance around. What's the circumference of our mint?
Wait, what's the diameter?
7.5.
24.5.
24.5. And our last object, very fitting for our time, our jar of wipes. You want to measure it?
Sure.
Okay, so Heather's measuring our wipe container, our diameter. So it's just a jar of Clorox wipes. So object 3, pipe wipes, and then tell us what our diameter is. past 10. Yeah, I would say probably about 10.4. So our diameter is about 10.4. So now go ahead and measure your circumference, which is that whole length around, and tell us what we get. I got a little bit smaller than that, so we're gonna round down a little bit. Yeah.
4 maybe.
Yeah, about 34. Okay, so now we have a table. We measured a bunch of diameters, we measured the circumferences. We need to figure out if the diameter of a circle is proportional to its circumference. So the first thing I want us to do is graph this table. So what that means is we're gonna go ahead on our x-axis and go over the diameter. So when I graph my point for Pringles, my diameter is 7.5. So come all the way over. We're counting by ones here. So 5, 6, 7.5, and then up to 24, which might be about here. So we did this measuring stuff yesterday. We graphed some kind of funky looking points. We were understanding that it's okay to not be 100% accurate. Now we want to graph the tape. So come over to 11, up to 35, maybe about here. Your mint is 7.5. And then I'm about 25.5, which is basically almost right on top of that same point for your Pringles. And then I have the Clorox wipes. So I have 10.4, a little bit past 10, all the way up to 34, so maybe about right here. So those are my 4 data points. It only seems like we have 3 because we can see in the table that the information for your Pringles and your mint can are very, 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 very similar. So then I want you to grab your line tool, start down at the bottom, and see as best you can how well you can fit it into your points. So it's kind of like what we looked at yesterday. So what would we say? Proportional or not proportional? Elena?
Proportional.
Yes. Okay. So all we did yesterday was talk about how it might be a little bit off, but all of these measurement errors are happening. We are messing up with the rulers. We have a little bit of a better ruler today than we did yesterday. We're estimating where the points are, so it's okay to be a little off, above, or below. Now I want you to take your calculator out. Does anybody need a calculator? I want you to figure out what the constant of proportionality is in the table. Okay. So we're finding the constant of proportionality in the table. That means you go in for your Pringles can, take the circumference, this is 24.2, divide it by 7.5. What do we get for the Pringles? Chris?
3.2666666.
So I'm gonna say about 3.2. For your tape, 35.5, divide it by 11. What do you get? Sydney? 3.2. For your mints, 24.5 circumference, divide it by 7.5 diameter.
3.266.
And your wipes, 34 divided by 10.4. What's your constant of proportionality there?
3.2.
3.2. So this is showing us that we actually did a really good job staying nice and consistent with our measuring. Does my constant of proportionality show me that they're proportional or not?
Yeah.
Yes, because they're all the same, okay? So we have a constant of proportionality between the diameter and the circumference, about 3.2. So I am gonna make a statement. We were a little bit off with our circumference measurements, okay? Because there is one specific set number that you are always going to get when you take the circumference and divide it by the diameter. So we were a little bit high when we were calculating our circumferences, which is fine because we were consistent in everything. It ended up being proportional. So we can say for this case that in our table, our constant of proportionality is 3.2. But we want to be careful because we did mess up a little bit. We measured things a little bit too big. Our constant of proportionality is a little bit too big. In general, when I take the circumference of a circle and divide it by a diameter, you are always going to get a constant of proportionality of 3.14. Does anybody know what that number is? Has anybody heard that number before? Rich?
Is it from pi?
It's from pi. Okay, so no matter what circle you have, if you take the circumference and divide it by the diameter, your constant of proportionality, if you measure it 100% accurately, your constant of proportionality is always that 3.14 number. Again, we were a little bit off. We were measuring a little bit too big and estimating a little bit too wide. So it's okay because our data worked out and showed us that it was proportional. But if everything is 100% accurate, this is always your constant of proportionality, taking a circumference to a diameter. Okay? I'm going to switch us to the next slide. Where we have to fill in a table. So we're given 5 circles. We're given the diameters and the circumference. Again, key information here is that no matter what circle you have, if you have a perfect circle and you're measuring it perfectly, so we're under the impression that whoever measured this did it 100% accurate, your constant of proportionality is 3.14. That's where pi comes from. You take the circumference and divide it by the diameter. So if my diameter is 3 centimeters, how do I find the circumference?
You divide by 3.4.
I have 3 centimeters. How do I make it bigger to get the circumference? Times it. So take your calculator, do 3 centimeters times 3.14. What's the circumference of a circle that is 3 centimeter diameter?
9.42.
9.42. Now I have a 10 centimeter diameter. Constant of proportionality is 3.14. What's your circumference? Go ahead.
Me?
Yep.
31.4.
31.4. Now your next 2 rows are a little bit different. Now you have your circumference. So we know how to fill out these tables from last unit. If I have 24 on the right, how do I go backwards to get the number on the left?
You divide it.
So 24 divided by 3.14 is what?
7.6.
7.6.
4, 3, 3, 1.
Yeah, so we can cut it. You can cut it. Then I have an 18 centimeter circumference divided by my constant of proportionality of 3.14. And what's that last diameter? Go ahead, RJ.
5.7.
5.7. So the constant of proportionality in any circle that you will ever come across, taking your diameter to your circumference, is always 3.14. So if my diameter is 1, what's that circumference going to be? 3.14. Okay. That is key piece of information that you need to know for your practice problems. When you're talking about the constant of proportionality from a circle, it's always pi. It's always 3.14. You can type in the number 3.14, or you can use the pi button that's actually on your calculators, but that's always the constant of proportionality that we're going to use. Are we good? Okay, so you guys at home can sign out of here, sign out of this Desmos, and go into your practice problems. It's a handful of questions similar to this. And like again, key piece of information is that your constant of proportionality is always pi. So you can get started on those. Please sign back in 9th period for your attendance to see what else you need to work on. You guys can get started on your practice problems now. There's plenty of time for the piece on. There's plenty of time to work on those and get those done. You finish them in here. You can go over the 9th period, and then you're going to work on those career projects. What are you asking?
Was I missed the title for the sentence?
I did.
Can I write them?
You were right.
The circles. I know that.